In this quick review, we want to begin our discussion of counting methods. And the counting method that we'll start with is what is called the multiplication rule for counting. And so the definition works like this. If a task consists of a sequence of choices in which there are P selections for the first choice, Q selections for the second choice, R selections for the third choice, and so on. So there could only be 3 selections you need to make, or there could be 100 selections you need to make. Then the task of making those selections can be done in P times Q times R times how many ever there are different ways. Okay, so it's counting the number of different ways you can make these selections. All right, so what do I mean by task and a sequence of choices? Let's work 2 examples. So the first one is about counting the number of possible outfits. So let's say a man has 10 work shirts, 4 pairs of work pants, and 2 pairs of work shoes. How many different work outfits does the man have? And assuming that everything matches. Okay. Well, looking back, this man has a task that he needs to complete. And what the task is here is they have to select their work outfit. And it turns out that this work outfit has a sequence of choices. Well, first the man has to select his work shirt, then his work pants, and then his work shoes. So how many different work outfits does this man have? Well, let's take a look. So there are P selections for the first choice. Well, it looks like there's 10 work shirts to choose from. And then, well, now the gentleman is going to go select his work pants. Well, how many options are there here for Q? Looks like there's 4. And then how many work shoes does this man have? 2. So how many total outfits? Well, 10 times 4 is 40, times 2 gets me 80 different work outfits. All right. So just what you're noticing here is there tends to be a multiplying effect when you want to count the number of different ways a selection can be made using this multiplication rule for counting. Let's do one last one. So a man has a 6-digit PIN for his, let's say, his ATM card. The pins, all right, are made of digits from the number 0 to 9. Okay. The pins if made from the digits from the number 0 to 9 and repeats are allowed, how many possible pin selections are there? Okay, so basically this is what's going on. This man's pin is made of 6 digits, okay? And we just want to know not what the man's pin number is, but how many different pins are possible, okay? It's telling you it's made from the digits 0 through 9. So 0 through 9 means there's 10 numbers there, okay, including 0, right? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 would count to 10. And repeats are allowed. So what this means is a pin number could be something like this: 5, 5, 3, 2, 1, 1. Or it could literally be 0, 0, 0, 0, 0, 0. Okay, and everything in between. All right, it could even be 1, 2, 3, 4, 5, 6. Okay. So how many possible pin selections are there? Well, look, you have a task you need to complete. Okay. And the task here is selecting the pin number. And it consists of a sequence of choices. So for your first digit, well, how many options do you have? Well, it can be any number 0 through 9, which would be 10 options. And then when you go to your second digit, well, how many options do you have? Again, because repeats are allowed, you have 10 again. And then for the third digit, 10. For the fourth digit, 10. And fifth digit, 10. And then the sixth digit, 10. So the total number of possible pins here would just be 10 to the 6th power. Or there are 1 million possible pins. Okay. All right, we'll follow this up by talking about some different counting methods in the next quick review. But as always, if you have any questions, please reach out to your instructor for additional help.